In this exercise, we'll be exploring some new terms. With these terms, what is involved is a pair of parallel lines, like I have shown at the bottom of the screen. There is then a line which cuts through the parallel lines. So let's look at some of these terms. The parallel lines I have now highlighted in yellow, and the line that cuts the parallel lines is called a transversal. I have highlighted the transversal in green. When we have this situation, there are a number of angles that are created. 1, 2, 3, 4, 5, 6, 7, 8. These angles have a number of special relationships, and we give these relationships terms. So I'm going to take you through those terms now. Here are our parallel lines with the transversal. So the first one we're going to look at are called alternate angles. Alternate angles are on opposite sides of the transversal. Your textbook highlights these lines that I have highlighted here. In this case, then this angle here and this angle here are alternate angles. That is, they are equal to each other. That is not the only way I can see alternate angles on this diagram. I will show you the other example. This time, if I go this way, there is an alternate angle here with this one there. So the alternate angles are sitting here and here where I've put the red crosses. These two are alternate to each other. Using my blue pen, this one here and this one here are alternate to each other as well. The next relationship we're going to look at is called corresponding angles. Corresponding angles are shown on this diagram here. If I mark in here in yellow, like the diagram in your textbook, what we can see is in red, this angle here and this angle here are the same. They are what we call corresponding angles. They're on the same traversal, in the same position on the parallel lines. Now, you can see the definition says above or below, because the angles I've marked in red are the same. This time changing to blue, this one here and this one here are the same. They are also corresponding. The ones in the blue are above the parallel lines. The ones in the red are below. Like with alternate angles, that is not the only way we can see this. We could have this situation. So we can see some alternate angles here. Again, using red above the parallel line, here and here, those two are corresponding to each other. In blue, below the lines, here and here are corresponding to each other. Corresponding angles are equal. The third type of angle we're going to look at are called cointerior or allied angles. There is a diagram of them there. Interior means inside. So, like the diagram in your textbook, inside between the two parallel lines, I will mark in red the cointerior angles, here and here. There is a difference though. These two add up to equal 180 degrees. Like before, that's not the only place I can see them on this diagram. If I consider my parallel lines this way, there is another set of co-interior angles. I will mark these in blue, here and here. These two also add together to equal 180 degrees. This is the first example in your textbook. It says, name the angle that is A alternate to C. C, I have circled in red. So if we want the angle that is alternate to it, if you remember the diagram like that, the alternate position is F. So alternate to C is F, this position here. Part B asks us for corresponding to E. So E is sitting just here. So corresponding position. So look at our two parallel lines and look at our transversal. E is above the bottom of the parallel lines, which means that A is in the corresponding position. So we have A corresponding to E. Here is the second example. It says, find the size of each labelled unknown angle. Looking at our diagram, we can see we have 64 degrees here. Just looking at the diagram, you can see that X is the same as the 64 degrees. It is in the alternate position. So X is equal to 64 degrees. For part B, we have Y and 37 degrees. Looking at the diagram, you can see that they are not equal to each other, but they are inside a pair of parallel lines and on the same side of a traversal. So what we know is they are co-interior. And what we do know is co-interior lines add up to equal 180 degrees. So we know Y plus 37 degrees equals 180 degrees. If we take 37 from both sides, like that, we get Y equals. 180 minus 37 is 143. 143 degrees. For the third example, it says, find the size of angle A. Explain how you obtained your answer. We know this angle here is 35 degrees. If I extended those parallel lines and took my transversal and extended it, you can see it is just like a diagram like that. So we know that A must equal 35 degrees because they are alternate to each other.